So we are continuing from the second one. The atomic size decreases from going across the period. The reason being is that the number of shells are not increasing. So the max you can say is that the size is not increasing, but in general the size decreases a little bit. The reason being is because the nuclear attraction or the nuclear charge is increasing. Nuclear charge, the positive charge is increasing, which is exerting more attractive forces on the electron, and those electrons are going to be pulled a little bit closer to the nucleus due to increasing charge and attractive forces. Do you understand this point now, Alishba? Any confusions? Hmm?
Yes, sir. No confusions.
All right, let's move on to the next one. All right. All right, so let's move on to the next part, the trends in the group. All right, trends in the group.
Yes, sir.
In the group. What does this mean? It means down the group. Down the group. Let's take group 1. Let's take group 1 as an example. We'll take group 1. The elements of group 1 are what? Lithium, lithium, sodium, potassium, rubidium, calcium, and the last one, FR, I just forgot the name, but it's there. FR. So these are the elements of group 1. When we talk about the trends that are taking place in the group 1, basically down the group, what is going on? Number 1, down the group, the atomic size increases, right? Why is that happening? Can anybody tell? As you go down the group, you see this would be the period 1, this is period 2, this could be the period 3, this is period 4, this is period 5, this is period 6, period 7, right? 1 2 3 4 5 6. So period 6. So if you go down the period, you're going to see that the number of shells is increasing, right? So lithium will have 2 shells. 2 shells. Sodium will have 3. Potassium has 4 shells, 5 shells, 6 shells, 7 shells, right? P7. So if you're going down the period, you're going to see that the number of shells are increasing. If the number of shells are increasing, it means the atomic size is increasing, right? As the number of shells are increasing, right? If you look at sodium, sodium is 11. So sodium has how many? Sodium is 2 8 2 8 1. How many shells this sodium has? Sodium has a sodium atom has how many shells? जी अलिशबा जल्दी से, how many shells does this have?
जी सर.
How many shells sodium has? Sodium की कितनी shells हैं?
1. Sorry, 3.
3 shells. If you look at potassium, potassium is 19. This is going to be 2 8
2, 8,
8.
8.
How much does that make? 1. So how many shells does this?
4.
potassium atom has? So 4 shells. This has 3 shells. It means in which period is it?
First.
Which period is sodium?
One. Oh, one.
Any period. I'm asking you which period is it in? Number of shells is same as the number of period, right?
Yes.
No.
Yes.
So which period is this going to be? It has 3 shells. It means
Third.
it is in the
Third.
third period, right? It has 1, 2, 3, 4 shells. It means it is in the 4 shells means it is in the fourth period. Yes or no?
Yes.
Similarly, lithium is going to have 5 shells. If you see that the number of shells are increasing, this has 2 shells, this has 3 shells, so it is bigger. Do you understand? Do you understand? Sodium,
Yes.
why is the number size increasing? Down the group, the atomic size
Yes, sir.
increases. Why? As the number of shells is increasing. Is this clear? The next trend, is what? This the second the if you go down the group, and again the second point, down the group, what happens? This is for metals basically. Down the group generally in uh, if you go down the group, the atomic radius increases. What is atomic radius? It's distance. What atomic radius? Distance from nucleus to last shell. So as the number of shells are increasing, the atomic radius will increase, right? Yes or no? Hmm?
Gcse.
Number 3, important point. For metals down the group, metallic property and reactivity increases. If you do go down the group for metals, we are talking about group 1, 2, 3. If you go down the group for metals, the reactivity increases. Why? Because as the size is becoming bigger, if you see this is an electron. I want you to concentrate. This is the electron and this is the nuclear charge. As the attractive force, it is going to have some amount of attractive force, right? If you move on to this one, the electron has moved further away, right? The atomic radius has increased. So the attractive force between these two electrons would be lesser, right? More attraction due to small distance, and this is going to have less attraction, right? Do you understand this point? Yes or no? As the
Yes,
size
sir.
has something, if you pull the magnets away further away, their attractive force becomes weaker, right? If you bring the magnets closer to each other, their attractive force increases. Similarly, if you're going to move the electron further away due to increase in the shell, it has only 2 shells, 1 and 2, but the shells over here have increased. If you're going to move the electron further from the nucleus, its attractive force will become weak, and so it tends to lose faster, right? There is no attraction from the nucleus. It can leave the shell. It can go out of the atom easily, right? Do you understand this point? So if so this is what the
जी सर
metallic property was. If the metal is able to lose its electron even faster, it means it is more reactive. अगर कोई मेटल जो है वो अपना इलेक्ट्रॉन जल्दी से लूज कर देता है, तो इसका मतलब क्या हो गया, वो क्या हो गया, ज्यादा रिएक्टिव हो गया, राइट? है ना? अब यहाँ पे अट्रैक्टिव फोर्स कम हो गई है, तो क्या हो रहा है, वो इलेक्ट्रॉन जल्दी से लूज कर रहा है ना? इलेक्ट्रॉन जल्दी से अपना इलेक्ट्रॉन दे देता है. यू अंडरस्टैंड? मेटल्स तो इलेक्ट्रॉन डोनर होते हैं ना, दे रहे. इज दिस पॉइंट क्लियर टू यू?
जी यस
आर यू श्योर? नो नो, नो क्वेरीज?
यस सर नो नथिंग
All right. Then number 3, the proton number also increases, right? The number of proton also increase. Or let's just write about the metals as well. Let's just complete this. Number of proton also increases, right? And what about the metals, non-metals? For metals, for non-metals, what happens is, for non-metals, the reactivity decreases. All right, we'll study that inshallah. Why for non-metals going down the group the reactivity is decreasing? Because it's again related to the nuclear charge, right? If you go down, what happens? The size is increasing, the number of shells are increasing for everything, right? For metals, for non-metals, the size increases. As the size increases, the nuclear force becomes weaker. So it becomes difficult for an atom, a non-metallic atom, to accept an electron. You understand? Because there is less attractive force now. Do you get it? So you can say the bigger the metallic ion is, the stronger, more reactive it is. The smaller the non-metallic ion is, the the stronger its uh, force of acceptance is. You understand this point?
जी सर
All right. Inshallah, we'll keep it till here, inshallah, and then we'll discuss further, inshallah. Okay? Okay, we have to discuss about the ions, how the ions, the size of the ions for if you go around them. So these are the few trends that we have to keep in mind. Inshallah, as we are doing past papers, we'll find more, we'll discuss them frequently, and you will be able to memorize them, inshallah. Let's call it a day here, inshallah, and then inshallah. Okay. Any queries?